Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is use of a portable pressure calibrator as a troubleshooting tool. This topic is being presented by Steven Saban from Druck. Steve has been involved in helping customers identify the right solutions for their instrumentation requirements for over 30 years, and specifically for pressure measurement requirements with Druck since 1996. First as a regional sales manager, then going on to assume multiple other roles in sales, sales management, product management, and marketing. Steve is looking forward to sharing some of the experience Druck has gained from providing pressure measurement and calibration solutions to customers over the last 50 years. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Steve.
Thank you, Christina, and welcome everybody. Thank you for joining us. We're grateful to have this opportunity to share this information with you today. We hope that you find it informational and educational. By quick way of introduction, some of you may or may not be familiar with Druck as a company. I thought I would just take 1 minute and give a brief history. The company was founded in 1972 in England by two gentlemen that started the company, and so we are celebrating our 50th year, which is pretty good going for a pressure measurement, pressure instrumentation company, which is our sole focus and sole purpose, providing customers with high quality, robust and reliable solutions for pressure measurement, pressure sensors, as well as instrumentation for calibration. So with that, I'll dive into the agenda that we're planning to cover with you today. So first thing that I wanted to do was go through a definition of troubleshooting, and then talk a little bit about the process of troubleshooting, and then try to go through a typical scenario that will highlight some of the capabilities of a portable pressure calibrator that can be used in performing that troubleshooting exercise, specifically for a pressure transmitter, and then take you through a few practical considerations when, again, doing that troubleshooting, and then talk about some other devices that a portable pressure calibrator can be used for troubleshooting exercises. So the scenario of a pressure transmitter, but obviously it could be used for other things, and we'll discuss that a little bit. So definition and process of troubleshooting. So I should caveat or qualify, I'm not purporting to be a troubleshooting expert. I found these definitions on the website when I went looking for something to concisely and precisely define and outline and provide some framework for this conversation. So the definition I just pulled off Google, I've cited it appropriately, I think. It's been a long time since I've done citations, but you can find them at the end of the presentation if you want to look at those. The process of troubleshooting, I found this one on a Lean Six Sigma definition.com webpage, and it seemed like a good set of steps for troubleshooting to me. When I was looking for this, you can find on the internet troubleshooting guidelines that go anywhere from 3 steps up to 9 steps, I think I saw. So this one seemed like a fairly concise set of steps, so I chose it to go through. So concern, cause, countermeasure, and confirmation. Probably the one that we will be talking about most will be cause, determining root cause of failure. So let's go through those steps. Typical scenario involving a pressure transmitter. So concern. Something happens, right? Here in our picture, we have manager, process instrumentation manager, whoever it may be, monitoring their processor system, and something happens, right? An alarm goes off, you're getting an intermittent signal, faulty reading, etc. Something happens that starts to cause a concern. And then what happens? Of course, you, the technician, or a technician gets called into the manager's office and says, hey, we have got a problem. I need you to go check it out. Of course, the technician says, no problem, boss, I'm on it. And then we head out to the actual site or location to start our investigation in determining root cause. So that's where we come to our portable pressure calibrator, because what do we take? We have to take something out there to be able to check it and test it. And one thing that we can do is that we could grab a number of items that we think we might need to do to test and check the site, the transmitter, the installation, etc. So we'll need a pressure reference, something that we know is working properly, to be able to check against the device or unit that seems to be having an issue. We'll need a multimeter, preferably one with a built-in power supply, so that we could energize the circuit and or the unit that we're testing. Obviously, some test leads. If we have a multimeter that doesn't have a power supply, we'll need to bring one of those. We'll have to have some way of generating pressure, probably most commonly a hand pump, although there are other options. And then we'll need some adapters, some way to connect our equipment, our pressure references, our multimeter, our pump to the device, and possibly hoses as well if it's a device that's in an installation that we can't remove or directly connect to. So we could take all of those things, which a lot of our customers have shared with us in the past, that it's a little bit cumbersome and a little bit awkward to take all of those different items, or they could take a portable pressure calibrator. This is one of ours. We're using our equipment. The intent of the presentation today is to be information and educational, but we are using our equipment to illustrate the use of a portable pressure calibrator, and I think it's hard to avoid, certainly for someone of a commercial orientation like myself, to do some promotion. So I'll apologize, or maybe not apologize for that in advance, but that is a Druck TPI 610 portable pressure calibrator. There are other similar products available, and some of the features and functionalities that I'll go through on this are common to many of them. Some we believe are unique, but hopefully all helpful and useful to you in possible future troubleshooting efforts. So I just wanted to take, before we go into the actual process of troubleshooting, when we're on the site, I wanted to quickly 101 review of what's involved in a portable pressure calibrator. So hopefully you can see my cursor on your screen. Could somebody confirm, Christina, I should have thought to do this before. Can you confirm that you can see my cursor?
Yes, we can.
Okay, thank you.
Yep.
So we have our test port. This is where you would connect your device under test or unit under test. We have pictured here on this picture a dirt moisture trap, which we recommend the use of to prevent any the process materials from the device you're testing getting into the unit itself. We have electronic interconnects for the powering up and measuring the output of devices. Down at the bottom here, we have our pressure pump built into the unit for generation of pressure to the test port. So we have a gross pump on this side, and then a volume adjuster for fine adjustment on this side. And we also have a selector switch where you can reverse the stroke of the pump to generate vacuum. On the side, which you can't see in this picture, there's a connection for external remote pressure sensors for expanding the pressure range capability. Obviously, we have our display Touchscreen display also can be operated through the buttons, ending up at the vent valve here, which you can open up to bleed off pressure to start your calibration, and then obviously close it when you want to start generating pressure. And then again, not visible from the picture here, we have up at the top here a cover, gasketed cover for the battery charger connection, as well as a USB port for interconnection with a PC for transfer and exchange of data. So that's all those instruments that I showed on the 2 slides previous, combined into one handy instrument that also has a very ruggedized and convenient handle so that you can grab it quickly to head out into the plant, into the shop, into the field, whatever it is you need to do to go to the site where you're going to be doing your troubleshooting. So here we are at our location, and this is simplified schematic to illustrate that here's our troublesome pressure transmitter connected to a quote-unquote receiver, which could be just a simple indicator, controller, computer, data logger, DCS system, PLC, you name it. So probably the first thing that we want to do in our troubleshooting effort is to do a loop check, make sure we actually have continuity from the transmitter to our controls. If we don't have that, then there's something probably wrong with the cabling, although I'm going to hold off drawing conclusions till the end. So we could perform that test with the built-in loop generation capability function. We could do them, it's probably energized, so we would just use the milliamp or current measure capability on the calibrator for this particular step of troubleshooting. And then we could go on to the next step would be isolating the transmitter itself from the controls. And again, with the portable pressure calibrator, we can generate a pressure to the transmitter and measure the output from. So isolating the transmitter, we can power the transmitter with a 24-volt source again available in the calibrator and measure the 4 to 20 milliamp current off of the device. And then finally, we can isolate the transmitter from the controls and again use the portable pressure calibrator to check the receiver by simulating the transmitter signal. Most portable calibrators, certainly ours does, have built-in process automation functions so that you can not only simulate that, you can enter in the exact value of current or milliamps that you want to inject into the controls, or you can set up automated process like step checks or span checks or zero to span ramps for checking the full range of the input to the receiver. So hopefully through one of those steps of troubleshooting, we've identified an issue. So just very generically, and again, very simply, I think we recognize that troubleshooting exercises don't always work out so simply where you just go and you check it and, oh, great, here's my problem, here's my fix. Understand that, but for the purposes of our conversation, we're going to make that assumption that that's happened in our scenario. So if in step 1 we went out to check the loop and there was no signal, then we could possibly, as one possible cause would be cut or damaged cables. There could be other reasons why we wouldn't have a completed loop. So the one possible countermeasure would be to replace or repair the cable, obviously. If we perform step 2 in checking the transmitter and it was just dead on arrival. There was no signal. There was no ability to generate any signal out. It wasn't responding to pressure. Obviously, we would replace it or repair it. Probably the more likely scenario of having a spare and swapping it out. Or another possible failure mode in step 2 would be that the transmitter was out of specification. We found a zero or span tolerance error. So if it's a fixed range transmitter that doesn't have any zero and span adjustment capability, then we would probably have to again replace or repair. If we found the same failure mode where the transducer was out of specification, and it does have some digital adjustment capability, we could use the portable pressure calibrator to either make those adjustments on the device, whether it's adjusting potentiometers, hopefully not. Hopefully it has possibly some digital capability like a Heart Smart transmitter, where oftentimes portable calibrators have a heart communication capability, and you can make the adjustments to the zero and span to bring it into tolerance, so you could reconnect it and resolve the issue. But there's also the possibility of using the portable pressure calibrator to identify the zero and span offset errors, and then hopefully be able to make those adjustments in your receiver through a gain and offset adjustment that you could do in your controls. So those are where the portable calibrator could come in very handy, not only in making those determinations and adjustments, but also then when we step on to the confirmation step of troubleshooting, you can actually do a full calibration on the unit to ensure it's performing over its full range. Step 3, possibility of identifying a failure in the controls and the receiver. One possible failure mode could be a bad I/O card. It got zapped with an overvoltage, contacts corroded, whatever it might be. And then you could possibly repair and or replace the I/O card that the transmitter is connected to. So, and then my note below, as I said before, hopefully it sounds strange sometimes to say, I hope we find a problem, but if you can identify a problem, then you can fix it, right? If you can't identify a problem, it's hard to fix. So if it's none of the above or nothing similar to any one of the above that we were able to identify, then, we have as I said there, the dreaded intermittent failure issue. You're not being able to recreate it when you're at the site. One of the additional things that you could do with the pressure transmitter, and this is a feature function of the DPI 610E, others may have it. You could use the portable calibration in a transmitter simulation mode. So you can actually set the transmitter up so that the pressure input from your process is the input to the portable calibrator, and then you can scale a 4 to 20 milliamp signal output into your controls to replicate the transmitter, or you could set up a data logging file and measure the pressure over a period of time to see if you can identify when the transmitter is having its intermittent issue and try and tie it to some cause via the data that you took over a period of time. So those are some of the possible countermeasures that you could take. And then, as I said, the confirmation being the calibration that you would perform after you've done the fix or the install. Oops. For some reason, I'm not able to, oh, there we go. Sorry, the slides hung up on me there for a second. So some practical considerations. I have a couple of videos of just going through the process of connecting a device under test to the unit, setting up the channels to do the calibration. So here I'm showing you just a standard spark plug type pressure transmitter. This is one of ours. It's a Unique 5000, and there's an adapter that's going to enable us to connect the transmitter, which is our device under test, to the portable calibrator. And then I'm going to connect to the electrical connector my test leads to be able to energize it and read the output from it. So one of the considerations, you want to have a system that's easy to set up. We have a swivel bezel nut that rotates around the device under test rather than having to rotate the device under test around a fixed test port. And there's a piston seal arrangement there, so there's no flats on it. So you'll notice that was finger tight, and it's finger tight good up to 15,000 PSI. So here I'm making the connections to the electrical ports. So pretty quick and simple setup, hopefully. So now I just wanted to go through this video setting up the test channels, the channels 4 to actually perform the test. So showing the screen going into the calibrator mode. Right now I have both channels were set to no function or none. So this is the pressure channel that I'm just setting to pressure to use the internal reference sensor and to use it in the gauge mode or normal mode. We do have an internal barometer that we can add to gauge measurements to do absolute as well. I'm setting up the second channel, or channel 2, for the electrical functions. So I'm measuring current, and this is where I have the option to turn on the 24-volt power supply to energize the device under test. You'll see that there was also a 10-volt option there if you're doing transducer rather than a 4 milliamp transmitter. So again, fairly simple, fairly intuitive to set up the channels for tests. Now we're ready to actually generate pressure. So the first thing I'll need to do in generating pressure is to close the vent valve. And then I'm going to use the convenient, robust handle, generate pressure. I'd like to point out that that's one pump stroke. I'm getting about 25 PSI with this setup, with this transducer per stroke. So I'm going to go up to 75. It's a 300 PSI sensor. I just went up to 25% of its full scale range, 75 PSI. So we would expect to see 8 milliamps coming out. So I did a little bit of adjustment there, and it seems to have settled out fairly well. So one of the things, when you're on site, don't want to have to be vigorously pumping the pump generation to get up to the pressure that you need. So a efficient pump is a handy thing to have. So that was just a very simple example of applying some pressure. There are capabilities within many portable pressure calibrators to be able to capture data. So you can do this on a number of levels. Documenting, it wasn't my intention to go through a long and detailed discussion about documenting calibrators, but I wanted to cover the documenting feature because it can be very convenient in troubleshooting, because you can capture the data at the site that you're doing your troubleshooting, and then you can go back and review it to identify where an issue may have occurred to help you in your countermeasure or correction of that fault. So I just wanted to briefly go through this, how to set up a documenting calibration and then go back and review it. It could also be helpful when you get back in the lab and have to explain to the manager as to what happened, what you saw out on site, etc. So again, just showing a picture of the screen. I'm not a hand model. I hope you forgive me. I tried to use a pointer on some of the other videos. So here we're going through setting up procedures of the test. So there are, you can define the procedure. I'm going to pause this for 1 second if you don't mind. Oops. Sorry, folks. I meant to pause that and it went to the next slide. I wanted to explain just a little bit on what happened there. I went through it a bit quickly in the video. So we're retracing steps. Apologies. So paused it. What we're looking at here is, so you can actually set up a procedure on the unit itself where you define the input, the range of that input. You'll see here I've defined it as 0 to 20 psi. The output is 4 to 20. The number of test points, you can define the number of test points, and then the tolerance, where you have 2 tolerance measurements. One is a pass fail and the other is an adjustment. So I've set it at 0.2 and 0.1 respectively. So that's the first step of setting up a procedure that's saved on the calibrator itself. What I'll do now, and the next step, is go into my catalog of assets, which you again can save on the calibrator itself and then call up the actual device or device type that you're going to be checking. So I've set up all my parameters on the procedure. Then I go in and I only have one on this particular unit, so I'm going to pick that one. It shows me the asset ID, serial number, manufacturer, model, and location. It gives you the opportunity to record the current ambient temperature, pressure, and humidity, and identify a user ID, ask you if everything's right, and then when I commence the documenting test, it's telling me there that I selected a pressure range for the procedure less than what the actual pressure range of the calibrator is. Shouldn't be an issue. Oh gosh, I did it again. Sorry, folks. The thing that I wanted to highlight once we get to the actual calibration screen, which we'll do in just a second here, is that not only does it give you the ability to capture those data points, it actually shows you your tolerance banding for the pass fail and the adjustment that you defined in the procedure. So again, that it gives you actual real-time indication of whether a point's intolerance or not. Some of you may be math whizzes. I'm not. You might be able to do that calculation on the fly in your head. I can't do that. I think the error banding or tolerance down at the bottom of the screen that you see there is a helpful tool to have. So that's the setup of the documenting portion. You'll see up at the top of the screen here, and I'll point this out in the next one as well, that you can actually, it tells you or gives the operator direction as to what pressure they're supposed to be applying. So I'm going to go on to the next screen, and here you'll see that we have the calibrator connected to a different device, more of a process style transmitter that some of you may be used to or familiar with. So I'm going to do the test. The first thing that I'll do is I'm pointing out that I need to go to 0. So that's the button that I would push to save that point. It actually showed me that it was out of tolerance, and it asked me if I still wanted to take the point, which I did. Now I'm generating pressure to go to the first point that it's telling me to, which I believe will be 10 psi. I'll let it settle out for a second, make some small adjustment, and then take the second point. Don't worry, I've only got a couple more points. I didn't do a 10-point up and down calibration for this video. So good enough, take the point. Yes, do you want to take it? Yes, I do. Save it, go to the next one. 20 psi for the next one. which is the full scale. Just in the interest of full disclosure, on the previous one where I had the pressure transmitter close coupled to the test port, you'll remember I got 25 psi per stroke of the pump. On this one, I'm not getting quite that much, but I do have a significantly more volume on that hose that I've used to connect to the pressure transmitter. So not quite getting the same pressure amount per pressure stroke, but it's still pretty good given the volume that I got going there. So I took a reading at captured a reading at 20 psi, and then I went back down to 0. Gives you the opportunity to enter comments at the end of the calibration, and then you save that data. So again, hopefully pretty simple, pretty straightforward way to capture the actual data points while you're troubleshooting a device. And then the final slide here, just going through and reviewing that data that you captured in that calibration. So back to internal procedures, pull up the one that we just did, which is PTX2, and then it'll, oops, what did I do there? Yeah, there's the, so I didn't record both of them, but I did an as found and as left. And there you can see a table of the data that you took, the number of points, the expected input, the actual output, and whether it was a pass fail. And then the same graph for the as left. So hopefully that's helpful. Hopefully that's illustrative of just some capability of what a portable calibrator can do in helping you in your troubleshooting exercises. So just a brief word about other devices. So a pressure calibrator doesn't really care what it's checking. It's agnostic. So any kind of mechanical or digital pressure gauge, pressure switch, a vacuum switch, pressure sensor. We talk primarily about 4 to 20 milliamp devices, probably the most common, obviously, but there are the capability for low-level output, millivolt level output devices, as well as amplified voltage. We see those in various industries, smart transmitters, pressure-based flow meters, current to pressure converters, valves, valve actuators, leak testing functions. There's oftentimes pressure decay based leak testing functionality or tasks. Is probably as long a list as you can think of pressure based devices. A portable pressure calibrator can help you in troubleshooting and identifying root cause errors of those. So our quote template, or our PowerPoint slide template puts these slides in there. It's part of the template. So I thought I'd throw what I thought was a clever quote in there is, if your only tool is a hammer, every problem looks like a nail. So from Abraham Maslow, but just sort of along the lines of the thought of having the right tool to do the right job, the right tool for the right job. So I think that's the extent of what I had. So welcome any questions, and I'll hand it back over to Christina.
All right, thanks, Steve. That concludes our presentation portion of the webinar. We'll now move on to the question and answer session. Just a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. So let's move on to the first one. You made brief mention of the transmitter simulation function. Could you explain that in a little more detail?
Yeah, of course. Yeah, I didn't have I should have maybe done a little diagram or a graphic for that. I just put some text in there, but yeah, so try and recap what I said. If probably most helpful in intermittent fault condition. Um, you can configure a portable calibrator or portable calibrator so that it can measure pressure from your process, and then you can configure an output that's scaled accordingly. So if you had, say, the pressure range of the device that you were troubleshooting or the process that you're measuring, 0 to 100 psi, you can scale the 4 to 20 milliamp output from the portable calibrator to 0 to 100 psi, and then you can use that signal, um, maybe to control the process while you take the transmitter out of service and do some adjustments, or have to take it back to the shop, or have to go back to the shop to get a replacement, or as I mentioned, the data logging capability, where you're not seeing an issue while you're at the site of the troublesome transmitter, but you could data log. You could set it up for a periodic data capture interval, and you can set the time interval for a capture of the pressure measurement. And there's sufficient memory in the portable calibrator to do that for it's a number of days, depending on the interval of the time interval that you're taking data. There's plenty of room to log pressure data for a couple days at least. So that can be helpful. You might come back the next day and review the data, or download the data from the portable calibrator to see if it was measuring the same things that the transmitter in question was. It can be a very helpful feature in troubleshooting.
Okay, the next one, how do you isolate for testing a liquid system?
Good question. Yeah, I think, my experience typically is that there would be uh, some kind of isolation valve. Three-way block and bleed valve is very common in process transmitter installation. So you can isolate the pressure media from the process from the transmitter itself, and then there's additional test ports to be able to connect to the transmitter that bypass the process. In a liquid system, you do want to make sure, as I said before, depending on the liquid and depending on the amount, it might not damage the portable calibrator to failure, but you want to take measures to ensure that you're not getting your process media into the portable calibrator, into the plumbing of the pump system internally. So one of the reasons we recommend the dirt moisture trap, but you probably, if you're able and it's safe, to be able to clean it up, or flush the connections, the pressure connections out a little bit before you connect the calibrator to it. That's probably recommended. That's probably the best practice that I'm aware
Okay,
of. Might
the
be other ways to
next,
do it, but I think that's what's commonly done.
all right, sounds good. We'll go move on to the next one. The DUT connection doesn't look familiar to me, person saying this. Is it custom? And what length of line is available to connect to the DUT?
Uh, well, yes, it is custom in, so the design where we have the piston seal arrangement, so you just only need to tighten the spinning nut that we have onto it to hand tight. That is a specific design to our calibrator. We do supply adapters that go from that fitting to any number of common process fittings. Hoses, there's really no limitation on a hose. We provide some as an accessory. I'm guessing Transcat probably has some lines that provide fittings and hoses. You can buy your own if you wish to. We provide them as a matter of convenience. The lengths on ours are 1 and 2 meters, so 3 to 6 feet. But there's really no technical limitation on the length of hose you could go. There might if it gets too long, then you got too much of a volume, and that might have some impact on how much you have to pump. But I think probably 2 meters is sufficient hose for most installations where you can get from the calibrator to a transmitter that you can't remove from the process to check.
Okay, thank you. Is it a problem if liquid gets inside the pump of your instrument?
Yeah, again, you want to avoid it. And the reason we do supply the dirt moisture trap. But again, it depends on the type of liquid, and it depends on how much and how long it sits there. So if you got a little water or some other you know relatively non-corrosive or something, well, non-corrosive, you can pump it out, you could dry it out, and it's probably not going to cause you any issues. But if you get something corrosive in there, um, there are seals and O-rings out of necessity. That's just a need of any pump. It could damage it if it's corrosive material and if it stays in there for too long.
Okay. Do I have to have software to use the documenting and/or data transfer functions that you talked about?
No, you do not. So there, as I showed it in the presentation, I mean, that was all on the instrument. There is a USB port on the device that you can upload to a PC in a CSV file format that you can pull into a spreadsheet or any other program. You have it available digitally in that format. That doesn't require any specific software. We do have a software package that you can use with our instruments, excuse me, called Foresight 2.0, which enables some additional capability. You can have a database of instruments or tags, and you can have associated procedures and routines with those tags that you could download to the instrument, and you can pull up that routine in that device and do the calibration similarly to the way that I did in the video. You would have a bit more information available to you, and the setup of the test would be a few less button pushes. It'd probably be 2 or 3 button pushes to get set up, but it's not required. In actual fact, you actually get the software. You get a license for the software with the DPI 610 units for our software. So if somebody, you don't actually have to buy it, it's available to you. It's just a matter of communicating with us or Transcat to get the actual license.
Okay.
So the answer to the question, no, you don't need software, but you can have it.
Perfect. That looks like the remainder of the questions. So that's
Okay.
going to conclude our time for today. If you have any further questions or would like to find out more about Transcat's product and service offerings, you can contact us at 800-828-1470 or visit our website at transcat.com. Thank you for joining us. We hope that you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Steve, and thank you to everybody, and have a great day.
Thank you. Thank you, Christina.
Right. Thank you. Bye-bye.